I'm James Daniels. I'm an engineer on the Firebase team. Who here has used Firebase before? Cool. Got a good representation in the room. So I'm going to recap a couple little things. So might be a repeat for those of you familiar with the product. And then I'm going to jump into a live demonstration. I'm going to do some coding. Hopefully, that's the live demo warning. I'm on stage in front of a lot of people writing code. Sometimes things happen. But I'm lucky because I have a lot of rubber ducks here to help me out. So I'm an engineer on the Firebase team. What is Firebase? So Firebase is a suite of tools built onto Google Cloud at Google for you to develop applications faster, better, stronger. And the idea here is that we have developer tools, we have our backend services, we have tools for monitoring app quality, we have tools to help you grow your application, and then the all-important part is earning. We have tools to help you monetize. So on the developing side, we have the real-time database. If you're familiar with Firebase, that is the bread and butter. That was the product that Google acquired. The real-time database is a JSON store that synchronizes in real time to all your connected clients over WebSockets. It's pretty cool. This is a little bit of an outdated slide. We actually have a new service called Cloud Firestore, which I'll jump into in a second. We also have user authentication. This allows you to sign in your users. This product is free. It integrates with Google, GitHub, Facebook out of the box. And then you can also provide your own custom authenticators. So if you're in an enterprise environment, you can spin up something that interacts with your own backends. If you already have your own custom authentication app, maybe something legacy, maybe something you still want to keep up, but you want your mobile applications to be using Firebase, custom authentication lets you integrate the two. We have hosting. We have cloud storage. So this is uploading binaries. Cloud messaging. So Firebase Cloud Messaging is the new version, basically, of Google Cloud Messaging. It has a lot of new features, and it also integrates with iOS, which is pretty awesome. And then there's remote configuration. And I'm a backend guy. I'm a developer, so I like these. But there's also tools to help you make your apps better, right? So there's the test lab where you can submit your applications. It'll run robo-tests on them. This is also in iOS now. We also have crash reporting. And recently, about a year ago, we acquired Fabric. So the industry standard for crash reporting, Crashlytics, is now integrated into our tool set. We also have all of our Grow products and Earn. I'm going to be coding for you, so I'll skip over those. But if you need to grow your product and earn some money, check those out. So the idea with Firebase in general is we've actually written the client SDKs for you, right? In a way, it's a candy-coated Google Cloud, right? We've built these tools for you. We built the SDK. We built the SDKs in multiple languages. It's iOS, Android, web, C++, Unity, right? All kinds of stuff. And the idea is that the shape of the code looks the same. So when you go create a web app and you're calling the real-time database, it looks similar to the iOS. Sure, the APIs may be slightly different, but the same shape of the code applies. All of our client SDKs integrate with Firebase Authentication out of the box. So you log in, and when it makes requests against either Firestore or the real-time database, the user's logged in. You have those credentials. It's instantaneous. It's magic. And it'll just update the views on the page. They integrate with security rules. This is very important. If you have a Firebase project, maybe a demo project where you didn't secure things, you might have noticed us sending out emails about this. scanning for insecure security rules. The idea is because the client is directly interacting with the database, how do you do typical security? If you had a REST server, right, you'd, in the middle, between your app and your database, do all kinds of checks and verifications. This is actually where security rules come in. So it's a JSON structure. You can go in there and write rules. There's some great examples there, but I won't touch on that. But it's very, very important. And then finally, we added this last year at Next, is Cloud Functions for Firebase. This has been the #1 most requested feature since it was a startup. Like forever was cool, serverless, but I still need a server because you don't have compute, right? So Cloud Functions gives you a bunch of neat little hooks into Firebase. And this is just a flavor on top of Google Cloud Functions, right? So this is the Firebase flavor. And it just gives you extra hooks. You can listen to a path in the real-time database. You can listen to a path on Firestore. You can listen for users being created. So Firestore is more like a traditional database than the real-time database. If you use the real-time database, it's just a JSON store. There's some caveats. Querying isn't great. When you fetch data, it goes deep. It gives you all the data under that node. So it changes how you structure your data. Firestore, we started on this after the acquisition. We're like, well, how can the cool things about Firebase be brought to Google Cloud Technologies? And the cool things about Google Cloud Technologies be brought into Firebase. So it's kind of the peanut butter and jelly of the Firebase acquisition. And I will jump into this a little bit. So I'm going to flip over to the live demonstration. I'm going to be doing a little bit of coding. I'm going to write an application, hopefully. We'll see. Anything can happen. All right. I can't even control my windows. So what I've actually done here is, because the Wi-Fi can sometimes be a little flaky and node packages are a black hole, I actually went ahead and generated 2 projects and did some basic configuration on them, but otherwise they're blank slates. So what I did actually here is I generated an Angular application inside my Firebase function. So here, I just initialized Firebase in a directory. And it asked me what I wanted to enable. I chose hosting, I chose Firestore, I chose functions, and it created those directories for me. I then went up and spun up an ng application in the same one. So if you see here, we have our typical Angular. Who here uses Angular or has used Angular? All right, cool. So Angular is a framework, a web framework for building applications. The reason I chose it for this demonstration is just because I'm most familiar with it, and it'll let me get code done better, easier, quicker, and maybe you'll learn some cool things about Angular along the way. So that's the Angular application. I actually did a little bit of configuration ahead of time on this, where I just configured it to bring in the Firebase Sdks. So this is the Angular Fire 2 library. So with Firebase, we have our main SDKs, right? So we have our iOS SDK, we have our Android SDK, we have our Unity SDKs. We also built on top of these smaller SDKs, where they're basically a compatibility layer between whatever framework you're developing in and the main SDK. So Angular Fire is a library that I'm one of the maintainers of. And Angular Fire tries to make the Firebase JS SDK work a little bit better out of the box with Angular. So that means things like dependency injection That means things like observables rather than promises. And I'll touch on those when I jump into the code more. I also went ahead and initialized a Flutter application, just a default Flutter application. And I went ahead and pulled in a couple of the Firebase libraries. So this is the Flutter library. So similar to Angular Fire, we've built just a little compatibility shim on top of the SDKs. And what Flutter is going to do is if you're building for iOS, it's going to be calling the iOS SDK. It's going to do all the setup and hookups for you there. And then if you're using Android, it's going to do the Gradle builds and set up all the dependencies there. Who here has played with Flutter? Less people. All right, Flutter is a cross-platform development environment. So it's largely targeting iOS, Android, where you develop an application in Dart, and it allows you to compile for both iOS and Android in the same code base. It's actually really slick. So let's actually show the Flutter application. Cool. So right now I'm in the Flutter directory, and this is just straight off the press, Flutter initialize, new application. This is the directory structure. So here we have our dependencies. This is the main project root, walks through all that. Developer dependencies. It uses material design. It has a lot of nice things built in there. But the meat and potatoes of our code base is actually just here, simply in main.dart. So we build our main, our entry point, it runs the application. I build my app. There's a stateful widget, that's my home page. And then there's a home page state here, which actually holds the state. And that matters for hot reloading. I'll show that in a second. And here I'm building a new scaffold. I'm including the title bar, a body, and then an action button. So let's actually spin this up. We can just do Flutter run all. So that -D is telling it which device I want to spin up on. I'm just going to be using emulators right now, so this is configured to use the iOS and Android emulator. So it's building the application. You see it starting Xcode build here. The cool thing about Flutter is actually compiling down to the native bytecode, right? There's no performance loss because it's JavaScript or something like that where it's going through an interpreter. This is actually right to the bytecode. It compiles to a native Android and iOS application. So that just spun up. So let's go ahead and bring up our iOS and our Android simulator. And this one is acting up. There. Sometimes the Android emulator, you gotta do weird things to get it to work. But this is actually the base template that it built for us. So what we have is just an application. You see there's this main bar. That's the title bar. The cool thing is that it knows the interface guidelines for both Android and iOS out of box. So you'll note on the Android device, it's a left-aligned title, and the iOS it's centered, right? Both are going to look, they're both material design, because we chose that option. But they're both made to look like the native application themselves. And how Flutter works behind the scenes is this is actually more like how a video game renders, as opposed to, say React Native or Cordova or something like that, where it's a web page and you have to use CSS to make it look like a native application. This is actually rendered like a video game where it's actually painting the elements and it's just a canvas. So it's very, very fast. So here, this is the basic sample application. I did tinker with that, as opposed to counter. And this is just incrementing a counter. Now, why a counter? Why is the default template come there? So if I actually go to the code, and I change this, something stateful, and I go to my terminal, I can hit a lowercase r to hot reload those applications. So you see something stateful. Same in iOS. And if you notice those counters, I'm not putting that in Firebase yet or anything. Those counters are the state of the application in that widget. And I just changed the code and the view changed to represent that, and I didn't lose my counters. I can do a full reload with capital R. And now you'll see I have lost my state. So doing certain things, you'll need to reload the state, of course. But for most little minor operations in your app when you're doing some surgery, you can just change that, hit lowercase r, it rebuilds, keeping that state, which is very, very cool. So that's our Flutter starting app. Let's go over to Angular. So I'm just going to start ng-serve, spin up the application, and see what we have. There we go. We have an application running locally. So let's get coding and rip apart some stuff, do some Firebase calls. So I'll switch over to my Angular app. So this here, I'm pulling those libraries, Angular Fire 2. I'm initializing them. And then in the environment here, I've actually pulled in my Firebase environment configuration. So you can get this just by going to the Firebase console and hitting add a new application. And it gives you the JSON. It'll give you the plist if you're iOS or the JSON if you're Android. And you can just drop those into your projects. The cool thing here, like I mentioned, all the security is actually going to be based around the security rules. That's your way of enforcing access to your database. So none of this is private, right? It can be right in your GitHub repo. If it's open source, it can be in the open, so long as you have configured those security rules. And that's your gatekeeper, as opposed to trying to keep client-side secrets secret, which is impossible. Like, you can obfuscate, but anyone can reverse it. So let's go to our component, and we just have our base app component here. So let's do some stuff here. So I'm going to go ahead and create a constructor. And that's the all right, so I'll create my constructor. And the constructor allows me to use Angular dependency injection. So if I go ahead and pull in let's do authentication first. So I will pull in Angular Fire auth. Oh, backwards. And colon. TypeScript. I've been bouncing between Dart and TypeScript, so the typings are going to get me. So that's one of the nice things about Angular, and why I primarily like it, is it has a good TypeScript experience out of the box. So I'm now pulling in Angular Fire Auth. Like I mentioned, Angular Fire Auth is just built on top of the Firebase SDK. So I have extra calls here, extra candy coding. But if I ever need to call a Firebase Auth API, I can just do afauth.auth and then sign in anonymously or with phone number or email. But here, I'm actually going to go ahead and I'm going to keep track of the user. So I'll do a public user, behavior, subject, user. Let's pull in user, import user from there we go. So here I'm actually pulling in the type, and it's pulling in from Firebase. I have that installed. This is a behavior subject here, and I'll touch on what a behavior subject is. Here, who's here used RX of any form, like reactive programming? All right, a couple of you. RX is awesome. You should look at it. It's really hard to grok at first, but it does. I'm sure if you find a functional programming person at your company, and they'll just rant about it nonstop. So what I'm going to do here is I'm going to do afauth auth state. So the auth state is an observable that emits a new value whenever Firebase's auth state changes. So I'm going to subscribe to this, and I get a user. And I'm going to put that user into, I don't think I need this. Isn't this done next? Yeah. So now I'm inserting that into the behavior subject. So one of the things about observables is observables are just a sequence of values over time, right? They aren't actually stateful. So things like keeping track of my current user is often helpful to actually use what's called a behavior subject. So a behavior subject actually has state. So you can look at the current state whenever. So why this is important is, say I have a button. I click the button, and it does some action, and I care about who the user is or if the user's logged in. It's helpful to, outside of the observables, actually pull in the current user. And I can actually just shorten that. That's implicit. Or backwards, right? So now let's go ahead and add a login and a logout action. Let's actually console log that for now, just as we see what we're working with. So we'll console log the user. Let's add a login function and a logout function. So we're going to call this afauth.auth.signin with popup and const provider. And now we have to pull in Firebase. So we'll pull in Firebase, as well as the user type. And here we're actually initializing the Google Auth provider, and then we're calling sign in with popup. This is not specific to AngularFi, this is just the JS SDK. You can just ignore the AF auth section, where you go auth, sign in with popup, and then the provider. And then logout is very simple as well. So we're calling auth to get into that initialized JS SDK auth object, and then we call sign out. So that's that, and now let's add some stuff to our HTML. All right. Let's see, what did we call it? Login. And I have that backwards, don't I? I knew something went wrong. And let's only show the login if the user is not currently signed in. So ngf user, we'll do async triple equals null. So what we're doing here is the user, of course, is an async. It's an observable. So what we're going to be doing is looking, letting it resolve first here, working with that observable. And then once it's resolved, check whether or not it's triple equals to null. And then we'll add a login. Similarly, we can do a logout. All right, and if the live demo gods are good to me, we see this login button. Let's bring up the Chrome inspector here. Let's hit login. No. So that's the current user state. And I messed up something. Oh, need quotes. Yeah. And the paren too, right? Good call. Rubber ducks at the ready. So we hit login. And now we've logged in. Oh, the given provider is not enabled. I just created a new project. So let's actually go ahead and turn on Google Auth and go to sign-in methods, and let's turn on Google Authentication. That's a good idea. So there, now we're logged in, and we see the logout button. We can hit log out, we can log back in. And you'll see here it consoled out the whole user object from Firebase. So we got a lot going on. We got my display name, my horrible, when Gmail first came out, username. Everyone's embarrassed of their first email address, right? Archangel is Microsoft Flight Simulator. That was my call sign. And we have a bunch of metadata and keys here, as well as the URLs. So let's go ahead and do something a little bit more interesting. Let's go ahead and get some data from Firestore here. grabbing my speaker notes. I don't have a second screen, so I got this little iPad stand here. It's pretty slick. So what we want to do in getting the data, we actually care about who our user is, but we want our collection to change based on the user logging in, logging out. So what we're going to do is introduce a couple operators on top of our observable. So we can go ahead and do afauth.authState. So we care about the user. And instead of subscribing to it, instead of calling the current value, what we're going to do here is pipe it. And I'm going to create a new observable. So let me import switch map. From RxJS operators. So what we're going to do is we have a user, and now we're going to turn it into another observable and swap it. So a switch map is like a map. A map just replaces something in line, right? You replace it with something else. A switch map allows you to switch it for an observable, but the cool thing that it does is it cancels all the prior subscriptions to that prior value. It cancels everything out. There are cases where you have to be aware of that side effect, but for authentication, that's exactly what we want. When the user logs out, we want to stop listening to the database at that path and instead listen to it at a new place. So if there's a user, then what we're going to switch map it for is actually, let's pull in Firestore from So we're going to pull in Angular Firestore module. We can now bring that in here. Public AF Firestore, Angular Firestore. And now we'll swap out the user for something interesting. So we'll pull in Angular Firestore. And we'll do a query on a collection. Let's say bonuses. So we can do things like this. Let's do messages for now, because I think I have something in that. We'll do of, and then an empty array. So observables are the base concurrency primitive in Angular. That's the large reason why we built Angular Firestore. And here I'm actually doing a query on the, this is wrong syntax, slightly different syntax in here. So this is built on top of the JS SDK. In the JS SDK, you would have done it like I just did, where you do .collection, .where, and then build on top of it. But there is a slightly different SDK at work here. So we're listening to the messages, and then this is a query builder. So we're going ahead and checking where the 2 equals the user UID. And then we're listening to value changes. If there is no user, just do an empty array. Let's return those. Let's do public. That was an array. Let's pull an observable. And that error's gone away. And now to see what we're working with, let's subscribe and just console log it. So empty array, we're logged in. That's probably because of my query. And then empty array when we're logged out. Let's log back in. And let's see, what's my UID? So let's grab my UID here. And we'll go to the Firestore. And I don't have a to field. So let's change to that user. And you notice something changed in the background. That was actually the return. So this is actually making a live connection to the database. So whenever anything changes in the database, it gets updated here. Let's add that to the view. Real quick, we can just do, what did I call it, messages. And that, again, that's an async. And let's call that. And we have to get rid of the subscribe. And this is cool. And let's go ahead. That's printing out. So let's go. And modify some values. And you'll see that update in real time. And that's really the benefit of making these observable based, is that's actually doing the binding to the view. The Firestore or the real-time database is actually keeping that connection open. If I wanted to just get it once, there's ways of doing that. I could just do a get instead of a subscribe. But by default, this is a good way of interacting with your database. Now, what I'm doing here is this is value changes. So this is unique to Angular Fire. So the value changes is just getting the raw base object out of the database. And then when the user's logged out, we return this empty array. And the cool thing here is this is automatically going to clean up all of our prior subscriptions. So this is one of the powers of reactive programming. I'm doing this switch map. And if I were writing this just by myself, right, I'd have to do a lot of ifs. I'd have to do a lot of else's. I'd have to cancel subscriptions. That's a lot of work. And anywhere where you have a condition, you're bound to mess up. So I'm going to cheat here and running a little low on time. So I'll pull my Dart code. Okay. And of course, there's a conflict. All right. So I made a small modification here. I'm actually Now swapping out the body, let's see here, body channel, and I'm wrong, I want the incoming change. So I'm swapping out the body for a message list component. The message list is now this block of code. So this is a stateless widget, all the states held in Firestore. So I don't care if a reload destroys it. I'm actually initializing Firestore. This is the build method. So whenever this gets instantiated, it's going to call the build, and this is going to draw the components. So this is a stream. This is Flutter's, like an observable, right? It's a stream of values, an observable. And it's an observable of query snapshots. So the stream source here, that's this argument, is coming from the Firestore messages where approved, true. So Firestore collection messages, where approved, true. And if you're familiar with the real-time database, one of the cool things about Firestore is I can append more where conditions on here. And they're all ands. We can pull in the snapshots from that. And if it has data, if it does not have data, it's loading, right? So let's put a text widget in there that says loading. Let's get the count, and then create a list view. So this is really common in programming with Firebase, whether it be Flutter, JavaScript, iOS, Android. You actually include your drawing code inside that callback, right? You can do some performance tweaking on top of it, but the idea is that whenever that callback triggers, it's because data in the database changed that you care about. So let's redraw the list, right? So this is now the item builder, so we send it the count. This would be just like a recycler view in Android or a list view on iOS. And we have this builder. We grab the document snapshot, and we'll do a title from the document message, and then a subtitle from the from name. So let's go ahead and save that and reload. So there, we see the wow. And just like on, let's bring those back up. Come on. And just like on web, if I go in here and alter things, it updates in real time. So we didn't get very far in building our application, but we got interacting with the Firestore. We got interacting with authentication on the web. But we have some next steps. We could use FCM for our push notifications. So the idea with FCM is you can register for those push notifications. It gives you a token. You could then call that token against the admin SDK. And be able to send a push notification. iOS, Android, and the web browsers that support it. That's the reason why I didn't build the Angular app as a PWA. I showed the Flutter is particularly on iOS. Safari doesn't allow web push yet. The app that I was building, we wanted integration with our LDAP. I'll touch on that in a second. We need to add the security rules, of course, to make sure that our data is secure. And then, finally, with the Flutter app, we can build production versions of our application, but we need to sign those. So you can sign those using Fastlane. That's a tool that I like to use, open source. It allows you to log into the Apple developer portal, pull the credentials, sign the application, all built in Ruby. It's a cool script. And we could deploy that to an MDM server if we're doing an internal deployment. And that formula allows you to build, especially for an enterprise app, internal use very, very quickly. If you're interested in actually deploying your own app, seeing how you could integrate with legacy endpoints or SOAP APIs or do some extra cool stuff, our boot camp on Friday, Firebase plus Apogee. So Apogee being the API portal, and we'll do some cool stuff where we'll actually allow third parties access to our Firestore data. And you'll actually get to deploy your own application.